All right, so this is my first video on binomial expansion. This is going to be a rather easy video on binomial expansion. We don't have ridiculously large numbers, but I'm just going to show how the binomial expansion process works. So if you recall, the formula for the binomial expansion is that suppose you had x plus y to some power n, and you're expanding it. Well, that becomes the sum of all of the terms from some index r equal to 0 going all the way up to n of n choose r times your first term to the power n minus r times your second term to the power r. Now this is a little bit complicated unless we see it in action. So let's go ahead and find our values of n. Well, our value of n is 6. That's our value of n. So as I go through, I'm going to note that I'm going to be dealing with 6 here and all of these things. Now, what's my value of r? Well, my value of r changes each time, so it starts off being 0 and then it grows up. What's my value of x? Well, my value of x is simply x, because it's the same. So I'm going to have that x occurring in the same spot. What's my value of y? My value of y is just positive 1. So everywhere where I see a y, I'm going to be dealing with a positive 1. So I can go ahead and substitute some of these things in. So this is going to be x plus 1 to the power 6 is equal to the sum from r equals 0 to 6 of 6 choose r, x to the power 6 minus r times 1 to the power r. All right, now I have to go through this summation 7 times. And the reason why I go through 7 times is because r starts at 0 and it goes through, and then it changes to 1 and it goes through and 2 and so on and so forth until it gets to 6. That's like the ending spot. So we'll set r equal to 0. Well, that's 6 choose 0, x to the power 6 minus 0, 1 to the power 0. And then we'll go to 1. So that's 6 choose 1, x to the power 6 minus 1, 1 to the power 1. And then 2. And 3. And at this point, I wish there was a way to fast forward. I'm sure that there is. Hopefully you are fast forwarding. Fast forward pretty much until you get to that spot there. Oh, I've run out of room. I'm not going to be able to squeeze it in. Okay. 6 choose 5. Whew, there's only a couple left. X to the power 6 minus 5. 1 to the power 5. And lastly, my 7th term, 6 choose 6. X to the power 6 minus 6. 1 to the power 6. Whew, 6 terms. All right. Let's count them to make sure they're all there. By 6, I mean 7. 1, 2, 3, 4, 5, 6, 7. Huzzah, we got them all. Well, the exponents actually simplify quite nicely. I wanted to take a look at the exponents on the x terms. Notice those exponents just decrease the entire time. So my first term is going to have an exponent of x to the power 6. My second term will have an exponent of x to the power 5, then 4, then 3, then 2, and so on. I want you to take a look at the 1 term. Well, that exponent increases. But it's pretty insignificant in this example because 1 to every single power is just 1. So I'm not even going to bother writing it. So my first term is going to be something x to the power 6 plus something x to the power 5 plus something x to the power 4, something x to the power 3, something x to the power 2, something x to the power 1, plus something. Now, the somethings are the coefficients, and your coefficients if you have a nice, easy question, are these values right here. So how many ways can I choose 0 elements from 6 items? Well, there's only one way to choose nothing. And similarly, how many ways can I choose 6 elements from 6 items? Well, there's only one way to choose everything. Now, how I get the rest of these is I go over to Pascal's triangle, and I go down to the 6th row. That's the one containing 6. Notice there's 7 terms, 1, 6, 15, 20, 15, 6, and 1. Well, this is 6 choose 0, this is 6 choose 1, this is 6 choose 2, this is 6 choose 3. So 6 choose 3 is equal to 20. That's how we get that term. 6 choose 4, 6 choose 5, 6 choose 6. So we'll scroll back here. We'll copy those numbers over. 6, 15, 20, 15, 6, and 1. And now we've gone ahead and done our expansion.